Okay, so to find the arc length here, we're going to use that formula. So we have the square root of 1 plus dy dx squared. So we find dy dx. We get 1 over 2 square root of x. And then we plug that into our formula. So we're going to take this and square it and put it into our square root. And we're going to integrate that with respect to x. And what are our limits going to be here? Yes, good. So on the x-axis, we're going to go from 1 to 4. Now, I would strongly recommend simplifying this before putting it in your calculator, mostly just to save you a little grief putting it in your calculator. It can be a little bit tricky putting stuff like this in there. I know you guys know how to do it, but I would rewrite this as the square root, I'm sorry, not the square root, the integral from 1 to 4 of the square root of 1 plus 1 over 4x with respect to x. And you could, if you wanted to, even write this as a single fraction, and you could rewrite it in different ways. But this is a good integral here to type in your calculator and evaluate. Now, before we do that, let's go ahead and do this with respect to y also. And this one's going to be a little bit trickier because we're going to have to change variables here. So we're going to integrate the square root of 1 plus, this time we need dx dy. And to find dx dy, what am I going to have to do with this equation? Solve it for x. So we get x equals y squared. So then if we differentiate, take the derivative with respect to y, we get dx dy on the left side is equal to 2y. So then in our formula here, we're going to put the 2y and square it, and we're integrating with respect to y. The only other thing I need then is what my limits are going to be along the y-axis. So when x goes from 1 to 4, what is y doing? Yes. So when x is 1, y is 1. But when x is 4, y is going to be 2. And we get that just by plugging the x values in here. So this integral right here is going to give us the length of the curve, the square root curve from 1 to 4 along the x-axis, but with respect to y. So what I'd like you to do right now then is plug both of those into your calculator and see if you get the same answer. And maybe more importantly, see if your answer makes sense. It's not a bad idea to guess first. Here I know that from 1 to 4 on a horizontal line is going to be 3, so I know that from 1 to 4 on a curve, and this curve it's not curving a whole lot, so I know it's going to be a little bit bigger than 3. Not a lot bigger than 3, just a little bit. What kind of answers are we getting here?
It's like a small variation.
There's a small difference between them? Do they both round to 3.168? Some of you are figuring out the importance of typing this in correctly. A couple of things. First of all, be sure, some of you, it's nice because you have a calculator that shows you what it actually looks like. Some of you don't have that. But be sure you're typing it in correctly. Be sure you have the square root. All of this in your square root should be in parentheses. And then the 4x, that a lot of people will type that in wrong, because if you just type in 1 divided by 4x, it's going to do 1/4 times x, not 1 divided by 4x. So be sure you're typing it in correctly. And this is a great thing because if I evaluate both of these integrals and I know they should be the same and they're not, then I know I did something wrong. So I could start looking back at what I did and see if I can figure out where my mistake is. You should get a value of 3.168 for both of them. This is actually an example out of your book. So what we want to do here is set up an integral with respect to x to find the length of this curve on the interval from 0 to 1, and we're going to evaluate this one analytically. We're going to do it without the calculator. Let's ask the important question first. Are we going to have any trouble with this function on this interval? So let's just figure that out. We're actually not, but let's figure that out by taking the derivative. And we're going to need the derivative anyway, so this is going to be useful for us later. So I'm going to go down to the bottom here and evaluate the derivative of this. When I do that, what do I get? I'll take a couple of steps here. So we have 4 square root of 2 over 3 times, what's the derivative of x to the 3 halves going to be? 3 halves x to the 1 half. Alright, so the 3's are going to cancel each other out. The 4 and the 2 are going to cancel, and we have 2 here. So the derivative is going to be 2 square root of 2x. Now, is this derivative, first of all, is it defined on this interval? Is it continuous on this interval? Yes. Now, we would have trouble if we had to take the derivative again. But we don't have to take the derivative again as long as it's continuous here. So it's defined and continuous even at 0 because the derivative is just equal to 0. So we're fine. We're in good shape. So this is the derivative that we're going to use in our formula. So the length of the curve then is going to equal the integral, we'll take care of the limits in a minute, of the square root of 1 plus the derivative squared with respect to x. And what are the limits going to be here? What are our x values ranging between? 0 and 1. Now, since we need to evaluate this analytically, this would be a non-calculator question. The first thing that we'll need to do is simplify this square root here. So when we simplify that, we'll have the integral from 0 to 1 of the square root of 1 plus what? 8x with respect to x. So it would be a good idea here to write this integrand as a power. So that would be the integral from 0 to 1 of 1 plus 8x to the 1 half with respect to x. And substitution would be a great idea here. I would let this inside part be u. So if u equals 1 plus 8x, then du is going to equal 8 dx. So I need the 8 here in front of the dx, which means I need a 1/8 out front. And so with my substitution, I'm going to have 1/8 of the integral of u to the 1 half with respect to u. And the only other thing I need to get here are limits. If x equals 0, then what does u equal? 1. And if x equals 1, then what does u equal? 9. So we have 1 plus 8, that's going to give us 9. So I actually don't even need to worry about the x's anymore. I can evaluate this with just the u's. And so this is going to be 1/8 of the antiderivative of u to the 1 half is u to the 3 halves, and then 2/3 of that times 2/3. And we're going to evaluate that from 1 to 9. So we're going to evaluate that at 9 first. It's going to equal 1/12 of 9 to the 3 halves minus 1 to the 3 halves. So I simplified this and got 1/12, and I'm just evaluating the u to the 3 halves from 9 or from 1 to 9. 9 to the 3 halves would be what? Square root of 9 would be 3, and then 3 to the 3rd power would be, it's 3 times 3 times 3, 27. So this is going to be 27 minus 1, so we get 26 over 12, which is same thing as 13 over 6.